What algorithm does YouTube use to find similar videos, or LinkedIn to search for relevant posts and users? The answer to this question is recommender systems. While participating in the Digital Inclusion Challenge, a 10-day hackathon to improve equitable education, my team and I found that high school dropouts, 80% of which end up in jail, are unmotivated because teachers have little or no time to help these individual students. These are two main issues that recommender systems try to solve: save time finding resources and personalize recommendations to each user. A recommender system, hence its name, recommends items to users, or calculates how likely it is for a user to find an item helpful. Recommender systems can be split into two main categories: content-based and collaborative. Content-based requires data on your users or items, so if you don't have those, use collaborative models. Collaborative methods are based on interaction data, such as views, retentions, and ratings. This is represented by a user item interaction matrix. In collaborative methods, we could choose whether to use a model or not. If we choose not to, there are two things that we can do: find users similar to the current user and recommend their most popular items, or find items that the current user likes and recommend similar items. In these cases, similarity can be calculated by Euclidean distance or cosine distance. When using a machine learning model, the main idea is that the user interaction matrix can be approximately factorized. Each user and item can be represented by a vector, and to calculate how likely a user would use an item, we take the dot product and possibly put that through a function that squishes all numbers between 0 and 1, like sigmoid. We don't want to have to make these vectors ourselves, so we use gradient descent, minimizing the cost between items that exist in the user item matrix and our predictions. We train either the users or the items separately, training one while keeping the other constant, or we could train both at the same time. Regularization is an optional step, but it really does help, ensuring that only specific users have high outputs with specific item vectors. In content-based models, we assume that we already have vectors that represent users or items. In this case, we could still use the same machine learning model. The only question is how much we want to change the vector that we already have. This is how some hybrid systems work, making a user fill out a short quiz whenever they create a profile or upload a new resource. In practice, users don't like taking surveys to create accounts, but they're more than happy to do it to ensure that their content gets seen by the right people. In conclusion, collaborative systems are based on interaction, while content systems are given predefined vectors. Recommender systems have so many applications in this world, and education can be completely changed by them.